The buoyant force is greatest on a 10-ton ship if it is floating in freshwater, saltwater, liquid mercury, all the same. Okay, last call. The correct answer is D. 22 of you got that right. And some of you are saying, well, wait a minute. Liquid mercury has much greater density. But it's floating. Let's do a free body diagram. I've got the weight down, and the weight on a 10-ton ship is, coincidentally, 10 tons. That's why we call it a 10-ton ship. The only other force acting on it is the buoyant force up. And what's the acceleration of a ship that's floating? Zero. And that means that these two forces have to be equal and opposite by what law? By second law with zero acceleration. And that means that that buoyant force has to be 10 tons, whatever it's floating in. So what is different between floating in fresh water and liquid mercury? Yeah, how it floats, how low it floats. If I'm floating in fresh water, that boat, in order to float, has to have a buoyant force equal to 10 tons. That means it has to ride low in the water, low enough to displace 10 tons of water. But if I'm in a lake of liquid mercury, heaven forbid, that'll be green, I still have to displace 10 tons of liquid mercury. But it has a very high density, and so that means I don't have to displace a very big volume to get my 10 tons. So that boat's going to ride very high. It might not even be stable. It might just fall over in a lake of liquid mercury. But why was it floating in a lake of liquid mercury to begin with? That's silly. So, where are these people? They are at the Dead Sea, actually. That's what the intertube said. They could also be at Great Salt Lake. The Great Salt Lake has the same density as the Dead Sea. And if you go out there, you float very high, and you feel very grungy when you're done.